Good morning, everyone. Myself, I'm Ganga Bhavani, Assistant Professor in ECE Department. So today we'll discuss the topic frequency response and analysis of multistage amplifiers. Okay. So we have seen there are three types of coupling. Okay, three types of coupling of amplifiers. That is RC coupling, direct coupling, and transformer coupling. So first we'll study the frequency response of RC coupled transistor amplifier. Okay. So usually this type of amplifier is more popular because it is inexpensive as well as it provides excellent audio fidelity. Fidelity means distortion free transmission. Okay. So RC coupled transistor amplifier is more popular because of its inexpensive availability, and also it provides excellent audio fidelity. Okay. Excellent audio fidelity in the sense it will give distortion free amplification in case of audio signals to over a wide range of frequency. Now it is usually used for voltage amplification. Okay, RC coupled transistor amplifier is usually used for voltage amplification. Now if you look at this figure, this is what RC coupled transistor amplifier. Why we are calling it as RC coupled transistor amplifier is, here you're using this is one stage of amplification, transistor with R1, R2, RE, RC and CE capacitor, and even you can see here this is a second stage. Okay, you're using capacitor CC. Okay, this coupling capacitor CC is used to couple the two stages of the amplification. Okay, and why we are calling it as an RC coupled amplifier is you're using the capacitor CC in shunt with the resistance. So what you're calling it as resistance capacitance coupled amplifier, or simply RC coupled amplifier. Okay, and if you can see this R1, R2 and RE, these three resistors form the biasing and stabilization circuit. Okay, and coming to the CE, emitter bypass capacitor CE, it is used to offer the low reactance path to the output. Okay, so these are the elements present in the amplifier circuit. Okay, so the coupling capacitor basically it transmits the AC signal and it blocks the DC. So it is used mainly to provide a DC interference, to prevent the DC interference between the various stages and the shifting of operating point. Okay, so coming to the operation, when AC signal is applied to the base of the first transistor, it appears in amplifier form across the collector RC, collector resistor RC. So this amplified signal, it is given to the base of the next stage. If we just go back to the figure, you can see here. Okay, so first AC signal is applied through this input capacitor Cin to the first transistor. Okay, so the output is developed across this load resistor RC of the first stage. Okay, so whatever amplified output is available at this point, it is given to the base of the next stage through a coupling capacitor, to the coupling capacitor. So this amplified signal in the first stage is further given as input to the second stage. So on the whole again, further amplified signal is available at the output. This is how the transistor RC coupled amplifier in multi-stage functions. Okay, so the second stage is further amplification. Okay, now the thing to be noted is here is that total gain is now less than the product of the gains of individual stages. In ideal case, what do we expect? We expect that a multi-stage amplifier, the overall gain should be equal to product of the individual gains. But in practice, this is not happening so. The reason behind that is, if you observe in each stage will be having some impedance, input impedance. Okay, and due to this input impedance, there is shunting effect caused to the load impedance of the previous stage. Okay, so the effective load resistance of each stage is reduced because of the shunting effect caused by the next stage, input impedance of the next stage. So because of this shunting effect of the input impedance of the second stage, the load resistance of the each stage will reduce. So as a result, what happens? The gain of the each stage also is being reduced. Okay. So for example, if you see, if it is a three-stage amplifier, what will happen? First stage is followed by second stage. So what the input impedance of the second stage will offer shunting effect to the load resistance of the first stage. So as a result, first stage and second stage overall gain will be reduced because of the following stages. Coming to the third stage, if it is a three-stage three-stage amplifier, then coming to the third stage, the gain of the third stage will not change because it has not got any shunting effect by the following stage. So what if you are using a multi-stage amplifier, in general what happens is the gain of each stage is reduced because of the shunting effect caused by the input impedance of the next stages, following stages. So what in a multi-stage amplifier, the overall gain in practice will be less than the product of individual stage gains of the individual stages. Coming to the frequency response, if you can see the frequency response of an RC coupled amplifier, it is of this form. That is, in the lower frequencies, as the frequency is increasing, the gain is slowly rising. Okay, and between this range, that is audio frequency range 50 Hz to 220 kilohertz, the gain is remaining constant. And further after 20 kilohertz, the gain is again dropping down. We'll see the reasons why the frequency response is of this kind. Okay. Now at lower frequencies, less than 50 Hz. Lower frequencies, the gain is less either in lower frequencies or the higher frequencies greater than 20 kilohertz. We have seen that the gain was less compared to that of the mid frequency range. So first we will see at low frequencies why the gain is less. Okay. So even low, usually the reactance of a capacitance is given by what? Xc equal to 1 by j omega c, or it is equal to 1 by j 2 pi fc. Okay. So it is understood that as frequency increases, the reactance will reduce. Or in the reverse, if frequency is low, then reactance offered will be high. So for low frequencies, the reactance of the coupling capacitor is quite high. So as a result, what will happen? Only very small amount of the signal will be appearing at the output of first stage. Okay. So after each stage, what we are doing, we are making use of a coupling capacitor to transfer the signal developed to the next stage. So if for lower frequencies, if the reactance of the coupling capacitor itself is very high, reactance is very high means what it does? It will allow only small portion of the signal to appear at the next stage. Okay, that is regarding coupling capacitor. That is one reason why the gain is being reduced. The second thing, even the emitter bypass capacitor CE also the same. For lower frequencies, the reactance offered by this emitter capacitance also is quite high. So, and because of its large reactance at low frequencies, it will not shunt the emitter resistor properly. We have seen in amplifier circuit that for emitter, we have got emitter resistor RE and bypass capacitor CE. Okay, bypass capacitor CE. If for lower frequencies, emitter capacitor CE is offering high reactance. High reactance means what happens? Usually you are using CE in order to provide low reactance for the output. But for lower frequencies, what is happening? The reactance offered by the capacitance is high. Reactance offered by this emitter capacitance is high. So in other words, we can say that it is not shunting the emitter resistance properly. So because of these two reasons, what will happen is during the lower frequencies, gain of the amplifier will be less. Okay. One reason is that reactance offered by the coupling capacitor is high. So because of high reactance offered by the coupling capacitor, we will get only small part of the output small part of the signal will be appearing at the output. And because the reactance offered by bypass capacitor is high for low frequencies, it will not shunt the emitter resistor RE properly. So because of this reason also, the gain will be reduced. So these two factors will cause falling of the voltage gain at low frequencies. Okay. Then we'll study about mid frequencies. At mid frequencies, what is going to happen? Why the gain is remaining constant? Yeah, it is seen from the figure that voltage gain of the amplifier is constant during the mid frequencies. So compared to the lower frequencies, now the reactance offered by the coupling capacitor is somewhat low. Yes or no? we have seen that Xc is equal to 1 by 2 pi Fc. So compared to lower frequencies, now in case of mid-frequency range, the reactance offered will be somewhat less. So as F is increasing, reactance will reduce. So in the mid frequencies, the reactance offered by coupling capacitor is less. So definitely as a result, compared to lower frequencies, now the output at collector will be little bit more compared to that of the lower frequencies. So we can say that at mid frequencies, the reactance of the coupling capacitor is large. Okay. So as a result, what will happen? The gain will increase. That is, a larger output will be produced. So what indirectly mean to say that more gain will be achieved. Okay, that is on one side. On the other hand, what is happening is lower reactance. Okay, you are offering lower reactance means indirectly you are providing higher load to the first stage and hence a lower gain. Okay. So when you are giving when the coupling capacitor is offering somewhat lower reactance, okay, it is offering somewhat lower reactance means what? Indirectly you are giving more load to the first stage. Okay, so lower reactance means higher loading of the first stage. Obviously, when higher loading is given, definitely the gain will be reduced. Okay, so here again there are two factors. One thing is at mid frequencies, as the frequency is large compared to that of lower frequencies, now the reactance offered by the coupling capacitor is less. So because of this low reactance, what is happening? A larger portion of the input will be available at the output. So compared to lower frequencies, in mid frequencies, gain will be more because of the low reactance of coupling capacitor. At the same time, since the reactance of coupling capacitor is low, it is indirectly offering higher load to the input stage, that is first stage. So again, when you are providing more load to the first stage, then again it is indirectly understood that the gain is being reduced. So there are two factors. Because of one factor, the gain is increased, and because of the other factor, the gain is reduced. So these two factors cancel each other, and finally they will provide a uniform gain at mid frequency. Okay, we'll be having a uniform gain at the mid frequency. Then at higher frequencies, at very high frequencies, what happens? Again, at very high frequencies, what is going to happen? Xc will be very less. The reactance offered by the coupling capacitor is very less. So it is very less means in other words, I can say that we can simply replace that coupling capacitor by a short circuit. When you are replacing coupling capacitor by short circuit, what will happen? Even in mid frequencies itself, we have seen that when coupling capacitor is offering low reactance, we have said that loading effect was more on the first stage. Now if you are directly replacing the coupling capacitor by short circuit, still the loading effect on the first stage will be more. Okay, this loading effect on the stage will be more, and as a result the gain will be reduced. That is one reason. And moreover, at higher frequencies, capacitor reactance of base emitter junction is low, which increases the base current. So at higher frequencies, capacitor reactance of emitter base junction is also less. So as a result, what will happen? The base current will increase. Base current is increasing, then this will indirectly reduce the current amplification factor beta. Okay, so base current is increasing, as a result this current amplification factor beta also will be reduced. So because of these two reasons, voltage gain drops at the higher frequency. Okay, so only at mid frequency the gain is remaining uniform and it is somewhat higher compared to low frequencies and high frequencies. Okay. So then we'll see advantages. What are the advantages of RC coupled amplifier? So advantages of RC coupled amplifier, it has excellent frequency response. That is, you have seen the gain was almost constant over the audio frequency, that is 50 Hz to 20 kHz, which is a region of most importance for speech and music. So within this region, 50 Hz to 20 kHz, there is a region where there is a frequency range where we will transmit the speech and music signals. The second advantage is that it has got lower cost. It is of low cost because it is using only resistors and capacitors which are cheap enough. Okay. And the third one, it is very compact. Compact means it is smaller in size, as the resistors and capacitors are small and extremely light. Okay, so the three advantages of RC coupled amplifier are: first thing, it has got excellent frequency response in the mid frequency range, that is audio frequency range from 50 hertz to 20 kilohertz. And second thing, it is of low cost. And finally, it is very compact in size. These are the advantages. In addition to advantages, it has got few disadvantages also. The thing is, first one, it has low voltage and power gain. Okay, RC coupled amplifiers have low voltage and power gain. Okay, and this is mainly because of the low resistance presented by the input of each stage to the preceding stage. It is understood, it is already explained that because of the low impedance of each input stage, what will happen? It will cause loading effect, it will reduce the effective load offered to the previous stage. So as a result, what will happen? Gain of each stage will reduce. Only the final stage which has not got following stage, only the final stage gain will remain same. It will not reduce because it has not got any shunting effect by the following stage. So thing is, it has got low voltage and power gain. The next one, they have tendency to become noisy with age. That is, as days pass by, these RC coupled amplifiers will be noisy. They become noisy. Okay, and particularly in moist climates. Finally, impedance matching is poor. This is one more disadvantage of the RC coupled amplifier. Okay. Why impedance matching is poor? Because output impedance of RC coupled amplifier is several hundred ohms, whereas input impedance of speaker, that is, this is mainly used for audio signals. So what input impedance of speaker is only few ohms. See, if several hundred ohms cannot be matched properly with few ohms, that is why we say that impedance matching is poor. So only very little power will be transferred to the speaker. These are the disadvantages. Coming to applications, the RC coupled amplifiers have excellent audio fidelity over a wide range of frequency. So, as we have seen from the frequency response characteristics, it is understood that RC coupled amplifiers have excellent audio fidelity, mean they are giving distortionless transmission over wide range of frequencies. So this is the reason why they are being used as voltage amplifiers. Okay, and that too in initial stages of public address system. So instead of RC coupled amplifier, if other type of coupling is used, what happens is it will result in frequency distortion, which may be amplified in next stages. So in the first stage itself, if there is any frequency distortion, obviously whatever signal is given to the second stage, it will be amplified, including the distortion. So if other than RC coupled amplifier, if you use some other coupling in the first initial stages, this will reduce in frequency distortion, and this frequency distorted signal will be further amplified in the next stages. So as a result, even the distortion also will be more. Okay, that is second application. Coming to the last one, yes, because of the poor impedance matching, RC coupling is rarely used in final stages. It is mainly used in the initial stages of the public address system itself. So because of poor impedance matching, it is rarely used in final stages. This is about RC coupled amplifier. Next, we'll see about transformer coupled amplifier. Transformer coupled amplifier, let me just show you the picture, because just see. We have seen that in RC coupled amplifier, here from the collector, you had a resistor, RC resistance, and then we have given a coupling capacitor CC between the collector of first stage and base of the second stage. Whereas here, since it is a transformer coupling amplifier, they are making use of a transformer, okay, across the collector terminal of the first stage and base of the second stage. So since you are making use of a transformer, you are calling it as transformer coupled amplifier. Okay. So the main reason for low voltage and power gain of RC coupled amplifier, we have seen what was the main reason for low voltage and power gain of RC coupled amplifier? Because the effective load of each stage is reduced by shunting capacitance of the next stage. Okay. So if the effective load resistance of each stage can be increased, then the voltage and power gain also could be increased. This can be done by making use of a transformer coupler. Okay. So what happens by using a transformer coupled amplifier is, transformer has got a specific property that is called as impedance changing property. Transformer has a property called as impedance changing property. So by using this impedance changing property, the low resistance of load, that is load resistance of each stage is less, I told. because of the shunting effect. So this low resistance of the load of each stage can be reflected as high load resistance to the previous stage. That is, you are simply increasing the load resistance of each stage, which was reduced because of the shunting effect of the next stage in case of RC coupled amplifier. Here we will overcome the difficulty by making use of transformer which has got impedance changing property. So by using this impedance changing property, we are trying to increase the load resistance of each stage. Okay. So transformer coupling is generally employed when the load is small. So when the load is small, in such applications, we make use of transformer coupling. It is mostly used for power amplification. Okay. Transformer coupled amplifier is mainly used for power amplification. So a coupling transformer is used to feed the output of one stage to the input of the next stage. Here the primary of the transformer is made the collector load and its secondary is given to the next stage. We can just go back to the picture and see here. The primary is given to the collector terminal of the first stage, okay, and the secondary is connected to base of the next stage. Similarly, again here, the primary of the transformer is given to collector of this one, then secondary will be given to base of the next stage. This process will continue if it is a multi-stage amplifier. Operation, yes. When an AC signal is applied to the base of first transistor, it appears in the amplified form across primary of the coupling. Yes. So, see, when we give an AC signal over here, okay, this amplifier will amplify the AC signal. So, the amplified signal is appearing across the collector. Okay, collector, that is across the primary winding of the transformer. So, through this transformer, what is happening? Whatever amplified signal is there, it is given to the next stage through this secondary. Okay, through this secondary. So, the voltage developed across primary is transferred to the input of the next stage by the transformer secondary. So, the second stage renders amplification in exactly similar manner. Again, the same. Whatever amplified signal the second stage has received, it will further amplify it and the amplified signal will appear across the primary. And again, it is given to the third stage through the secondary winding of the transformer to base of the third amplifier. This process will continue. Now, if you look at the frequency response of the transformer coupled amplifier, we see that it is not constant over a wide range of frequencies. That is, it is not maintaining uniform gain. Okay. So, compared to the RC coupled amplifier frequency response, the frequency response of this transformer coupled amplifier is somewhat poor. It is not maintaining uniform gain anywhere. Okay. So, it is clear that frequency response is rather poor. That is, gain is constant only over a small range of frequency. Okay. Output voltage is equal to collector current multiplied by reactance of primary. So, at lower frequencies, reactance of primary begins to fall. Yeah, reactance of primary begins to fall. For transformer, that is, it is nothing but an inductor, windings are inductor. So, what reactance is given by J omega L. That is, reactance is proportional to frequency. So, at lower frequencies, what will happen? Reactance of the primary winding will be less. So, reactance is less. So, what the gain also will be reduced. Okay. Output voltage is equal to the collector current multiplied by reactance of the primary. Output voltage is equal to collector current multiplied by reactance. So, at lower frequencies, reactance is less means indirectly the output voltage also will be less. As a result, the gain also will be decreased. As a result, the gain also will be decreased. So, at lower frequencies, the reactance offered by the primary winding is less. Reactance offered by the primary winding is less means the output voltage also will be less. Why the output voltage will be less? Because the output voltage is equal to collector current multiplied by reactance of the primary. Okay. So, for lower frequencies, reactance offered by the primary winding is less. So, since the reactance offered by the primary winding is less, obviously the output voltage also will be low. As it is, so obviously if the output voltage is low, then the gain of the amplifier also will be less. So it is understood that for lower frequencies, the output voltage is less. As a result, at lower frequencies, gain will be reduced. What about at higher frequencies? At higher frequencies, the capacitance between turns of winding acts as a bypass condenser to reduce the output voltage and hence gain. So even at high frequencies also, okay, though the reactance offered by the primary winding is increased, though the reactance offered is increased, still you have some capacitance between the turns of windings. So between the turns of windings, you have got some capacitance, and that capacitance, what it does, and that capacitance is acting as a bypass condenser. So this will again reduce the output voltage. Output voltage is reduced, and definitely the gain also will be reduced. So even at lower frequencies, it is offering low gain, and as well at higher frequencies also it is offering low gain. So it follows therefore that there will be disproportionate amplification of the frequencies in a complete signal such as music, speech, etc. So transformer coupled amplifier introduces frequency distortion. So why we are saying that transformer coupled amplifiers are introducing frequency distortion? Because it is there is no proper proportion according which the frequencies components are being amplified. So it is indirectly saying that different frequencies are amplified by different amounts. So we say that in transformer coupled amplifier, it is introducing frequency distortion. Okay. So but in a properly designed transformer, it is possible to achieve a fairly constant gain over the audio frequency range, but a transformer that achieves a frequency response comparable to RC coupling may cost 10 to 20 times as much as the inexpensive RC coupled amplifier. So, in a if you are designing the transformer coupled amplifier properly, okay, with a proper design, it is possible to achieve uniform gain, but let me tell you, it will cost you 10 to 20 times more than that of the RC coupled amplifier. So whatever uniform gain you were getting with the very inexpensive, or you can say inexpensive RC coupled amplifier, almost you can maintain the same gain using transformer coupled amplifier also by properly designing, but it will be costing you 10 to 20 times more. Okay. Then coming to advantages of uh, transformer coupled amplifier. So first thing is no signal power is lost in the collector or base resistors. That is, power loss is not there. Okay. And next, an excellent impedance matching can be achieved. One disadvantage of RC coupled amplifier was that poor impedance matching. But coming to transformer coupled amplifier, excellent impedance matching is there, and no signal power is lost. Okay. And due to excellent impedance matching, transformer coupling provides higher gain. Okay, transformer coupling will provide higher gain compared to that of the RC coupled amplifier. Okay, so a single stage of properly designed transformer coupling can provide the gain of two stages of RC coupling. Right. So the single stage of transformer coupling amplifier will provide the gain of two stages of RC coupling. It will provide higher gain compared to that of RC coupling. Okay. This is all about a transformer coupled amplifier. Next thing you have is disadvantages. It has poor frequency response, that is, it is not constant over a given frequency range. Okay. The coupling transformers are bulky. It will occupy more space compared to that of the RC coupled amplifier. It occupies more space, as well it is more expensive. And even you have seen that there is some frequency distortion also is more in case of transformer coupling amplifier. And also it results in hum in the output. So transformer coupling also tends to introduce hum in the output. These are the four disadvantages. Poor frequency response, okay, and it occupies more space and it is more expensive compared to RC couple. Frequency distortion is high, as well it will introduce hum in the output. Okay. Next thing we have got is direct coupled amplifier. As the name itself suggests, direct coupled amplifier means you're not using any coupling element between two transistors, between two different stages. You can see here. First, the output of first transistor is given directly to second base of the second transistor. Again, the output of the second stage is given directly to the input of the third stage. If you observe here in the 3-stage direct coupled amplifier, you are making use of transistors in a different manner. First stage you are using an NPN transistor, second stage it is PNP, and again third stage it is NPN, like this. The alternate PNP and NPN transistors will be used to construct the direct coupled amplifier. So these are nothing but called as complementary transistors. Okay. T1 will be NPN, then T2 will be PNP, again T3 will be NPN, T4 will be NPN, PNP, NPN, PNP, like this. This arrangement will continue. So the weak signal is applied to, same procedure here, weak signal is applied first to the input of first transistor, and due to the amplification of the first transistor, what will happen? Amplifier output is appearing across load of collector load of RC of transistor 1. Then this voltage drives the base of the second stage. Okay, amplified output is again obtained across the collector load, and this process will continue for the further stages. Okay. Advantages of direct coupled amplifier are circuit arrangement is simple because of minimum use of resistors. You're not making use of any coupling, so our circuit arrangement is simple. Okay. Circuit has got low cost also because of expensive coupling devices are not being used. So what it has got low cost. And disadvantages, it cannot be used for amplifying higher frequencies. Direct coupled amplifier is always used only for low frequencies. And operating point is shifted due to temperature variations. That is, there is no stability of the operating point. If there are any variations in temperature, then the operating point will be shifted. Okay? And mainly coming to frequency response of direct coupled amplifier, we can say that it will act almost as a low pass filter, that it will provide high gain for low frequencies. Okay. Coming to application, low frequency amplifications and low current amplifications. So direct coupled amplifier is basically used for low frequency applications. And simply to say, frequency response will be as that of the low pass filter. Okay. You can have a comparison between all the three types of coupling. Frequency response it is excellent in RC coupling amplifier. It is poor in transformer coupling, and direct coupling it is the best for especially for lower frequencies. Coming to cost of RC coupling is less, and the transformer coupling is more, and direct coupling it is least. Space and weight of RC coupling is less, that is of transformer coupling it is more, and of direct coupling it is least. Impedance matching, it is excellent in transformer coupling. So as far as impedance matching is concerned, transformer coupling is excellent. Coming to RC coupling, it is offering poor impedance matching. Direct coupling, it is okay, good. Finally, RC coupling is used for voltage amplification. Transformer coupling is used for power amplification. And direct coupling is used for amplifying extremely low frequencies. It is to be noted. Direct coupling is mainly used for amplifying extremely low frequencies. Okay. So this is all about the frequency response and analysis of multi-stage amplifiers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.